All right, let's look at the homework 5.3, problem number 8. All right, so given the derivative and the point that the original function goes through, we want to find the function f of x. All right, so let's do that. All right, so we want to find the original function by taking the antiderivative of this given function. So you have a 2 over 1 plus e to the negative x with respect to x, right? So here's the trick. I'm going to multiply top and bottom by e to the x. So I'm going to multiply this guy by e to the x and multiply this by e to the x, right? Then you will see that it's going to look like this. First thing is, I guess this is a number right here. I'm going to kick this number outside. So we will get 2 outside. Then you have an integral, right? Then you have e to the x on top. And then we have e to the x is distributed to 1. So obviously you're going to get e to the x. And this is distributed to e to the negative x. Since they're reciprocal of each other, you're going to get 1, right? So dx. All right, then you can see that here the derivative of the denominator is exactly the numerator. So it's going to be 2 natural log of absolute value of e to the x plus 1, right? You don't really need the absolute value because e to the x plus 1 is never negative, but I'll put it in there anyway, plus some constant c. All right, then we just need to find c using this condition. So f of 0 is going to be equal to, so you have a 2 natural log of, plug in 0 there, so it's going to be a natural log of 2 plus constant c, and this is equal to 4. All right, so we can just simply subtract the 2 natural log of 2 to find c, which is a 4 minus 2 natural log of 2. All right, so therefore, original function is 2 times natural log of absolute value of e to the x plus 1 and plus 4 minus 2 natural log of 2. All right, so let's type it in. All right, so we have 2 times natural log of e to the x plus 1. And you don't really need the absolute value sign there. So you have a plus 4, actually plus 4 minus 2 natural log of 2. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.